we've already been factoring this semester. We learned how to factor last semester in Math 10. And we solved quadratics by factoring in Math 10. Normally in 10C we don't, but we did that because we're in IB and we needed to be able to do that. So this semester we're reviewing that, and then we'll learn the other methods of solving quadratics. So graphically, obviously, we just did, and then the quadratic formula is the big one that you're going to learn. So really have to get good at factoring. Some of you still struggled a little bit with completing the square when you were factoring for that. In any case, a polynomial is expressed in factored form if it's written as a product, so multiplication, probably with brackets. So these are in factored form, okay? And these are actually completely factored because within the bracket, there's nothing that you can do, no more that you can do. Nothing that you can divide into both of the terms in there. So each of these can be expressed in simplified form. To simplify, you multiply to remove brackets and collect like terms. So remember, some of you, I use that word FOIL to help me remember. So you multiply the first together, first terms in both brackets, outside terms together, inside terms together, last terms together. Okay, and then you collect like terms. So you need to get to the point that you're not showing 4 terms. You should be adding those like terms in your head now that you're in Math 11. So when we do the opposite of that, going from this to this, that's called factoring. So I guess the arrows are underneath there, right? So here, and then we're going backwards to factor. All right, so these are simple trinomials. That means the coefficient of x squared is 1. So when you expand back and collect like terms, notice that the last terms multiply to the constant term, and those two terms, values separately, add to the coefficient of x, because those, what gives you the middle term is the outside multiplied together and the inside multiplied together. So what is the connection between the values in the factors and negative 35? They multiply to negative 35. The values in the factors multiply to 35, and then they add to 2. Okay. So we must find 2 numbers that multiply to C and add to B. That was covering up something. Okay, so simple trinomials are the easiest. So basically, you can set up your factors right away. You don't need to show any work because there's nothing that you can divide out to start. Okay? So you're looking for, so in this case, if they're simple trinomials, the variables go in the first position, and then you're looking at the constant term, 2 numbers that multiply to 12 and add to 7. So you go through your factors, 1 and 12, nope. 2 and 6, nope. 3 and 4, yeah. And you can always check your work by expanding the back. Sometimes that's how you might end up factoring. It's just a little bit of trial and error that way. Okay, then here, 2 numbers that multiply to 15, add to negative 8. Okay, so they could both be positive or both be negative. Here, if they're both positive, they're never going to add to negative 8. So they both have to be negative. Okay, and you know 5 times 3 is 15. So negative 5 times negative 3 is 15 as well. just fill in your brackets. Okay, if your constant term is negative, then one of them has to be positive, one has to be negative. Okay, and so if you think of 7 and 5, if and 7 and 5, the bigger one needs to be the negative, so we need to make 7 negative 7, so that when we add them, we still get a negative. Okay, you do question 4 and 5 on your own right now. Hint in 5, common factor first. Okay, so if I gave you this to factor, so forget about what that question is. If I gave you this, then that would factor to a at the beginning. 40 is 8 times 5, so that would be a minus 8 times a plus 5. Okay, that would work. Notice that how these coefficients and constant term are the same. So this is really the same as a, and this is the same as a. So wherever there's an a here, I can put in the x plus 2. Okay. So if you have the bracket that's squared is the same bracket that's basically exponent 1 and then a constant, it's the form of a simple trinomial. And so you can factor it to that bracket, minus 8, times the bracket plus 5, and then collect like terms. Okay, so I can tell from that that if I had expanded out, yes, I would have been able to get that at the end. Okay, but something like the next one would be harder, right? Because there's really, when you expand the next one out, you have degree 4. We haven't quite, you will learn how to factor a degree 4, but we haven't got to that yet. So take a look at this one. Is there a squared bracket? There is. Is there the same bracket to the exponent 1? There is. Is there a constant term? There is. So factor, we'll move that together. Factor this expression, okay, and then replace a with this whole bracket. Just to like accentuate the fact that it's the whole bracket. Doesn't matter, you can use whatever you want. Okay, Okay, so 16 is 2 times 8, so this would be a minus 8, a minus 2. And so here, replace that with the bracket. Okay, then collect like terms. Question? You could, but really I'm not going to even mark this part. I'm going to this. Okay, so expand, collect like terms, and factor inside the big brackets, because you might be able to factor those again. Okay, so then you check, are there two numbers that multiply to -4 and add to -3? Are there two numbers that multiply to 2, add to -3? So you factor both. All of those factors are different. Okay, so those were all simple trinomials. Now the non-simple. So where you have a coefficient in front of x squared that can't be factored out. So here's an example. Okay, if I were looking to factor this, can't divide anything out. What's the connection between the values in the factors and 10? Well, the coefficients of the x terms multiplied to 10, right? So factors in 10. Okay, then the factors in -18, so the constant terms. And the values in the factors in -3. Okay, so now this is where your outside, you multiply that, and your inside add to -3. Okay, so the actually I'll simplify that. Okay, so that's just a connection. That's not going to necessarily factor it for you, but what that tells you, it helps you find the values. So we must find two numbers that multiply to something, find two numbers that, so basically here we want to find two numbers that multiply to A, two numbers that multiply to C, and the outside and inside product must add to B. So I simplify that a little bit by saying, I don't know what that was there for. So I find two numbers that multiply to AC and add to B. So that it combines that a little bit. Okay. Who has used decomposition, the method of decomposition to factor? So a lot of you, yeah. That's how I always teach it to start when you're factoring. And then hopefully you get good enough at factoring, may not even use decomposition. Okay, so Now that we're in grade 11, you want to get to the point that you don't have to show that work for factoring. Okay, so I still kind of use the sort of the setup for decomposition, but then I use a little bit of trial and error. Some students do a little box with crisscrosses in it. Some, there's a method called like over the rainbow, and then Australian method, and then there's different types, okay? Decomposition is the actual algebraic work. That's the real way to factor, but you can do it in faster ways. So I'll show you what I do for decomposition, and for my trial and error. I look for two numbers that multiply to 30. 2 times 15. And add to 11, coefficient of A. So when I think of the factors, 5 and 6 comes up right away. But I do not set this up as two brackets with A in front, because I know that I have to get 2A squared. So I make one of them 2A to start. Okay? And then I think, okay, how to get my middle term of 11A, I've got to go my outside and my inside. So look at these two numbers. That's what I have to get for my outside and my inside. Obviously, if this is a 2, this has to be a 3. There's only one even number there. And so the other one has to be 5. Right? Or you could look for factors of 15 and say, okay, well, is it 15 and 1 or 3 and 5? Right? So you can narrow it down that way. But that's it. Okay, so I didn't really show much work. If you had done decomposition, you would have done 2A squared plus 5A plus 6A plus 15. Right? You have to show that. Basically a right or wrong for factoring. So you show the work, but you've got to get to the point where you don't need to do that. So next one, 3 doesn't go into all of them, so it's a non-simple trinomial. I want two numbers that multiply to 3 times 8 is 24 and add to negative 10. Okay. So think about it. Could be some version of 12 and 2 or 6 and 4. So the signs are really important, right? It has to multiply to 24. So these would have to be both positive or both negative. So that's not going to work, right? That's going to work. That's not my value, my constant terms. That's what I get from my outside and my inside. Okay? So I know here, this is a prime number. Only choice is 3B and B, so B and 3B. And if I have to get these numbers, my only choice for 3B is for that to end up being minus 2 there to get negative 6B. And then that would have to be negative 4. So I'm going to leave the next few, and let's do 16 together. So you're going to work on those on your own. Let's do 16. Because it's one of those, actually, yeah, let's do 16. It's one of the harder ones, okay? So it's got a bracket squared, then another bracket that's exactly the same, and a constant term. So you can factor it in a similar fashion to that. 3 is not common. So then I want to think about, okay, two numbers that multiply to negative 30 and add to 13.
So you're probably thinking, okay, -10 and -3, or it would have to be positive, or +10, -3. But notice how they don't add to 13. Those don't work. So then think of other factors. Well, how about 15 and 2? So 15 and -2 add to 13, and they multiply to -3. So that will be these two numbers. Okay, so if I were to factor this, then to get 15, that would have to be +5 there, -2 there. So with my original brackets, that's my first step of factoring.
And again, in this one, if you did expand out, it probably would be able to factor it. But if you threw in an extra variable or something like that, or a higher degree within the brackets, you wouldn't be able to factor it.
Okay, so expand the brackets, collect like terms. Take a look at this one. It's got a common factor. So all of these you have to completely factor. That means I need to take out the 2 from there. Okay, I'll show it out front, and what I'm left with is x plus 3. So always check your final brackets. Final answer should have it out front. They'll put them on here out front. Okay, so that's, the next one's going to be similar. Okay, so you can finish off those ones in a few minutes when you have some time, and then factoring a difference of squares. These are kind of the most fun. Okay, so recall that if you're multiplying what we call conjugates together, so same terms, opposite signs, you only get 2 terms, and it's a difference of perfect squares. All right, so the product of a pair of conjugates is a difference of squares. So vice versa, if we have a difference of squares, we can factor it to the conjugates. So you want to look at what the 2 terms, are they perfect squares on their own? So 49a squared, yep. Square root of 7a, sometimes I just write it above. The 9, without the negative, yep, the square root of 9 is 3, and it's a difference. So as long as it's a difference, then it's 7a plus 3 times 7a minus 3. Or you can put the minus in the beginning and the plus at the end. Done, that's it. Sometimes you can factor again, so just always check your brackets. For example, here, the root of this is 4x squared. The root of 1 is 1. So this would be 4x squared plus 1, 4x squared minus 1. And then check. That's a subtraction. So and this is a perfect square, and so is this. So can't factor 4x squared plus 1 again. But you can factor 4x squared minus 1. Okay, so that would be 2x plus 1, 2x minus 1. Okay, 20's got fractions. So maybe you want to factor out fractions, but looking at it right now, actually I see a lot of perfect squares. So I'm going to factor it by difference of squares to start and then see what I can simplify. Right? Because this is a perfect square. The root is 3/5 x. And this is a perfect square. The root is 1/4. So one has a plus, one has a minus. Okay. So you could find a common denominator in each, like to get rid of the, show it, I would actually leave it like this. Particularly, this isn't going to be something that's a final answer, but if you wanted to not, with no fractions, then, or sorry, with integer terms inside the brackets, because we obviously have fractions, then common denominator would be 20, right? 4 times that, so that'll be 12x plus 5. This would be for 12x minus 5. And so really that's the same as 1 over 20 times 20 is 400. You could show it like that as well. Okay, similarly with a decimal. Let's look now, though, at 24. Okay, yeah, let's do this one here. So, perfect square, perfect square. Right? As soon as you see a square on a bracket, you know it's a perfect square. Difference. So this, you know there's brackets in there, so I'm actually going to start with square brackets. So the root of 9 is 3. The root of this is 2x plus 1. So I'll keep it in brackets. One has a plus, one has a minus. Really important to keep it in brackets, right? Because then you have to get rid of those brackets and collect like terms. So 2x plus 3 plus 1 is 2x plus 4. 3 minus 2x minus 1. So 3 minus 1 is 2 minus 2x. Take a look. There's a common factor in each of those. So there's a 2 from here. There's a 2 from there. And then if I multiply those together, again, showing those coefficients, that would be 4 times x plus 2. 1 minus x. You could even factor out a negative if you wanted to, right? To get the x's at the beginning. But that is fine as well. So you could factor out a negative 1 from here. 4 would be the same, the x plus 2 would be the same, and this would be x minus 1. Okay, so either of those. Okay, so I'm going to leave the ones that we didn't do together for you to do, and on the back of that there's more factoring practice with the answers there as well. So those ones on the back are a little bit harder. Okay.